In this video I'll go through Unit 1 Mechanics ISP Task 2 for Edexcel AS Physics. So if I scroll down to the task, we're really looking at the equations of motion for uniform acceleration, so the kinematic equations of motion as they're also known, and experiments and demonstrations we've performed to demonstrate the equations of motion and the value of g. Okay. So there's no explaining everything task for this week. I made a mistake in terms of what I copied in there, but if you want something like this to do, then it's demonstrating how we can measure the value of g would be the sort of task I'd ask for you to do. Alright, so let's skip straight to the questions. Task 2. Okay, so we've got a lorry that's accelerating at 25 meters per second down a mountain road. When the driver discovers the brakes have failed, she notices an escape lane covered with sand is ahead and stops the lorry by steering into the sand. The lorry is brought to a halt in 40 meters. Calculate the average deceleration of the lorry. So it's traveling. So let's list out what we've got. Remember, when you're doing equations of motion, you need to list them out of SUVAT. So S-U-V-A-N-T. Okay, they want the acceleration or deceleration. We know the final velocity needs to be 0. We know the initial velocity is 25 meters per second. That's meters per second. It says brought to halt in 40 meters. Time is not required, so therefore we want one with A, V, U, and S in. So it's V squared is equal to U squared plus 2AS. Look at your equation list and you can pick that out from there. So we want to rearrange for A. Okay, so you bring the U squared over first, so V squared minus U squared is equal to 2AS. Okay, then you want to divide by this 2 and S, because you want A by itself. So V squared minus U squared divided by 2S leads to A. Well, you know that V is equal to 0, so V squared must be 0, so minus U squared over 2S gives you A. Just bring the calculator into shot. So our initial velocity is 25 squared times, let's do this correctly, 0 minus 25 squared. Okay, and then we want to divide that by 2 times S, 2 times 40. Okay, so you end up with about 0.08, minus 0.08 meters per second squared. Okay, so about about 40. So for 40 meters, it's 0.08 meters per second squared was the average deceleration of the lorry. We'll just double check that by looking in the mark scheme. Skipped a bit further ahead than I need to there. Right, I've clearly made a mistake. I think I missed out the squared on the line above. This is why I double checked it. Let's do that again. So 0, I think I did 2.5 squared. Yeah, the 2.5 squared is what I did. So 0 minus 25 squared divided by 2 times 40, or just divided by 80. Yeah, that's much better. Okay, so you end up with 7.81 meters per second squared. I thought the answer was wrong there, so I thought I'd better double check the marks here straight away. Okay, but you would have been given the marks for that by the examiner. Okay, the examiners do allow for small errors in terms of typing buttons to calculate. If you show your method, like I did there, they would have accepted that. Okay, so just at the depth of the sand affects stopping distance. So if the sand was deeper, the stopping distance would be shorter, and that's to do with the idea that there'd be greater deceleration due to the fact there's a greater frictional force there. Okay, a student is working on a spreadsheet to model a fall of a golf ball from rest from the window of a tall building. He assumes the acceleration remains constant at minus 9.81 meters per second squared for the first 2 seconds of fall. Okay, so it's constant for the first 2 seconds of fall. Comment on whether this is a reasonable assumption. Yes, because it won't have reached terminal velocity. It won't have had long enough to reach terminal velocity, which is when the acceleration would have changed to 0. So B6 over it, so it's talking about the velocity reached, is calculated using the formula B6 is equal to 9.81 times A6. Explain why this is appropriate. So what they're saying essentially is, let's write this all out so you can see it. B6 is equal to 9.81 times by A6. So B6 is final velocity or velocity reached, 9.81 times A6. So A6 is time. Okay. Well, this is A. Well, this is G, which is essentially so this bit over here is acceleration due to gravity. So it's acceleration. So G or A you could use, and that's V, and that's T. If it's falling from rest, this could be U, but U is 0. Okay, so if it's falling from rest, U is equal to 0. So that's just using the equation V equals U plus AT. So that's why that is appropriate. So that proves the appropriateness of that equation, of the formula in a cell by using this equation to do that. Okay, so C7 is calculated by using the formula B6 plus B7 divided by 2 multiplied by 0.2. Explain what B6 plus B7 represents. Okay, so we're taking one velocity and the velocity after that and dividing by 2. So we're finding the average velocity. Okay, we're finding the average velocity because we're taking 2 and dividing it by 2. Okay, so that's the average velocity is what we're doing. Why is it multiplied by 0.2? Well, that's multiplying that average velocity by the time interval. Okay, so in other words, a change in time. So why is this fraction multiplied by 0.2? Because it's multiplying by time. And this allows you to figure out the distance. And if you look carefully, C is figuring out the distance travelled every 0.2 seconds. So all they're doing over here is multiplying average velocity by time to give you distance. Give an appropriate spreadsheet formula that allows D9 to be calculated from D10. Okay, allows cell D9 to calculate D10. So in other words, calculating D10 from D9. Okay, so you got D10, and you want to know how to figure that out from D9. Okay, so total distance from the start. So what you need to do is you need to add to D9 to figure out D10. You need to essentially add a value to D9 to figure out D10. Well, the value you need to add to D9 to figure out D10 is C10. Sorry, yeah, C10. The idea is that that's how much it fell in the first 0.12 seconds. If you add to that how much it falls in the next 0.1 seconds, this value over here, you'll end up with this one over here. Okay, so D10 is equal to D9 add C10. Okay, so if you struggle with spreadsheets, make sure you watch this part of the video again to make sure you understand what's going on there. You can check this spreadsheet model is giving sensible answers for the total distance travelled by calculating the distance using an equation from the list and the formula at the back of this paper. Okay, so that's in the ISP. Calculate the answer for cell D11. Okay, so they want us to calculate the answer for D11 using an equation. Okay, so we've got the time from the start is 1.6. So again, we're using the ISP there. Time from the start is 1.6. Initial velocity is 0. Acceleration due to gravity is 9.81 or minus 9.81. And they want to know the distance it's fallen. Okay, so we've got U, A, T, and they want S. So S is equal to UT plus half AT squared. UT disappears. Sorry, let me lift that up. There we go. We've got everything listed out. UT disappears. Sorry, just let me turn the backlight on my camera. Might make it brighter. Let's have a look. Yeah, that helps. Okay, so UT disappears because of the fact that U is equal to 0. So therefore S is equal to half AT squared. So we just have our numbers in now. So 0.5 times by 9.81 times by, now remember only the T is squared, so it's only the 1.6 being squared. I'm just making sure my calculator does that by putting it in brackets. That's about 12.55 or 12.56 it rounds to, which is exactly what D11 is there. Okay, so I proved that by using that expression. That's an A, by the way, there. Okay, so I proved it by using the expression and then also by putting it into the calculator. Excellent. Next question, question 8. Okay, standard question about figuring out how, time from other information. Okay, so we've got an astronaut dropping a hammer, acceleration due to gravity is 1.6 meters per second squared. How long does it take for the hammer to fall 1 meter from rest? Okay, so let's do that again. So 1 meter from rest. So from rest means initial velocity is 0. Final velocity, don't want anything to do with. Acceleration is 1.6. Time is what they want. So you want an equation with S, U, A and T in. So same as before, S is equal to UT plus half AT squared. Okay, there we go. Again, UT disappears because it's equal to 0. So S is equal to half AT squared. We'll rearrange for A. So 2S is equal to AT squared. A is equal to 2S over. So we're going to rearrange for T, don't we? Whoops. So T therefore is equal to 2S over A. T squared, sorry, is equal to 2S over A. T is equal to root 2S over A. Okay, so we'll whack that into the calculator. 2 times 1. So that's 2 divided by 1.6, so it's not 9.81. Common mistake, people write 9.81 there when they should put 1.6 in. So 2 divided by 1.6, and you want the square root of that. So that's about 1.1. 1.12 seconds. Okay. Calculate the velocity of the hammer just before it hits the ground. Okay, so velocity is V is equal to U plus AT. Okay, U is 0, so therefore it's just going to be V is equal to AT. We've got the acceleration, so I've got the time that we just figured out, multiplied by 1.6, which is our acceleration, so you end up with 1.79. So the velocity is equal to 1.79 meters per second. Okay, let's check the 2 parts of question 8. Nice 4-mark question to get, or 2 nice 2-mark questions to get. All these experiments we use to figure out the acceleration due to gravity, by the way, which I was mentioning earlier on in the video. There we go, so 1.1 and 1.8, brilliant. Alright, question 9. Which is the last question in this ISP task. Okay, careless soldier, very careless, shoots a bullet vertically into the air at 450 meters per second. Calculate the time the bullet takes to reach the top of the flight. State any assumptions that you've made. Okay, so time to top of the flight. So this bullet, let's put this down. There we go. This bullet is going to go up and then back down again. Okay, so at the top, the final velocity is equal to 0 meters per second. Okay, acceleration is equal to minus 9.81. The initial velocity is equal to 450 meters per second. Okay, the acceleration is acting in the opposite direction, so we need to use meters per second, minus 9.81. And they want to know the time. So we've got V, A, and U, and they want T. Okay? So V is equal to U plus AT. They want T, so V minus U over A gives us T. So let's sub in those numbers. So V is 0 minus U, which is 450, divided by A, which is minus 9.81, should give us a T. Minus 450 divided by minus 9.81. Down to the camera. So 45.8 seconds. Okay, that's how long it's saying it should take to get to the top of flight. So double check that again. It's a a fairly large number, so it's slightly concerning. You'd think it'd be slightly less than that, but then again, it is going very fast. Yep, so about 46 seconds. Okay. So because it's going so fast, that's what's taking so long. So to come back down again, it'll take the equal amount of time. Okay, so it'll be 46 seconds to come back down. So 92 seconds for that bullet to do a round trip up and then back down again. Okay. So, stating the assumptions we made. The main assumption we made is the no air resistance. They haven't stated that in there. Okay, but we know that in these situations, stating there's no air resistance, and that acceleration is uniform. Sketch and enable fully a velocity time graph for the bullet's complete flight. Okay, so velocity time graph. We know it's going to have negative velocities as well as positive velocities, so we're going to include that in there. Velocity and time. Well, there's only one acceleration acting in this entire thing, and that is the acceleration due to gravity. Let's just go a straight line like this. The gradient of this graph we know is going to be minus 9.81. Okay, we know that its initial velocity is 450 meters per second. We know again when it hits the bottom over there, that's going to be minus 450 meters per second. And we know that this time over here is 46 seconds at the top. They are the main features of this graph. Explain the shape of your graph. Constant deceleration of gravity, which has caused that gradient to be the way it is. Use the graph to calculate the distance travelled by the bullet before it hits the ground. Okay, so distance travelled, so that's the area under the graph. So we're looking at that area there, and we're looking at that area there. Okay, so it's another 46, so this is going to be 92. Okay, so if we've got the area of this triangle, I'll then double it. So the area of that triangle is going to be half base, 46, times height, 450. Okay, so 0.5, which is half, times the base, 46, times the height, 450. So this all comes, remember, from our idea that the area under a velocity time graph tells you the distance travelled. Okay, so this chunk over here is equal to 10,350 meters. Well, we need to double that because these two are equal, as we know. So we times that by 2. So we end up with 20,700 meters as a distance travelled. Sounds about right. It's a bullet going very fast. It should travel over a very large distance. That's 7 marks attached to those questions. So it's a big question to get. So you can see that's exactly the graph that we drew. Because you can see that over there we labelled all those features. We even added the gradient, which they haven't. So we talked about the fact that the straight line, because acceleration is constant, and again we gave that a value of minus 9.81. And there we go, 20,700 meters. Okay, so there we go. So that finishes ISP task 2. Okay, so thank you for watching, guys. The next video is ISP task 3, which is all about forces. Thank you very much.